10 myths about OWASP vulnerabilities that trick cloud professionals. OWASP is an acronym that stands for the Open Worldwide Application Security Project, and they are famous as a source that creates a lot of security lists, standards, and tools to protect apps, cloud services, and websites. Like this video, subscribe to the channel, follow the playlist, and visit systemsarchitect.io.
An ORM, Object Relational Mapper, or parameterized queries is what you need to protect from input. It basically means injection is solved for you. The database no longer trusts raw user input.
Only half true, and only for that one query path. An ORM, a helper that writes SQL, structured query language, for you, does block classic SQL injection. It fails on NoSQL, shells, templates, or prompts. Treat every external input as untrusted, not just SQL. Parameterized queries keep user values out of the SQL text. NoSQL injection, command injection, and template injection still land as hostile data outside SQL. LDAP, lightweight directory access protocol lookups, and prompt injection still land there too. What is insecure deserialization? Validate input, encode output, and skip insecure deserialization, rebuilding objects from untrusted bytes.
Server-side request forgery, SSRF, isn't a big deal in the cloud. There's no traditional server left to hit.
That's a myth, and the target moved to metadata. Classic SSRF, a server fetching a URL that the caller picks, did hit local files. It gets worse once that fetch reaches instance metadata. Cloud metadata services hand out temporary credentials to the instance. An attacker who reaches them can call your cloud APIs, block outbound fetches, and require a metadata token on AWS IMDS version 2, Instance Metadata Service version 2, Azure Instance Metadata Service, or the Google Cloud Metadata Server.
If a WAF, a web application firewall, sits in front, you're covered against the OWASP, Open Web Application Security Project, Top 10. Signatures catch injection, XSS, cross-site scripting, hostile script in a page, and the rest.
Wrong! Unless the attack matches a known pattern. A WAF, a filter that inspects HTTP, does catch many signatures. It fails on business logic flaws, rules the app should enforce. Keep the WAF as one layer only. The top 10 names the common web risks: AWS Web Application Firewall, Azure Web Application Firewall, and Google Cloud Armor miss hostile script in a page and checks your code never wrote.
If the API is behind an API gateway, authorization is handled. The gateway authenticates and applies policy.
Not quite, because the gateway is coarse-grained. It does prove who the caller is, which is authentication. It stops once you need fine-grained object-level or function-level checks. Authorization is what that caller may do to this object. What is BOLA? BOLA? BOLA, Broken Object Level Authorization, also called IDOR, Insecure Direct Object Reference, is swapping an ID to read someone else's record. BFLA, Broken Function Level Authorization, is calling an admin function with a normal user's token. Put those checks in the back end, not only on Amazon API Gateway, Azure API Management, or Google Cloud API Gateway. Learn more at systemsarchitect.io. Like and subscribe to the channel and follow the playlist.
Broken access control is mainly an on-premises web app problem. Cloud APIs don't expose those URL tricks.
Not true, and cloud makes it more common. Classic IDOR did live in a tampered URL on a monolith. It spreads once object IDs cross services and tenants. Check authorization on every request for every object. Horizontal privilege escalation is reading a peer's data. Vertical privilege escalation is acting as an admin. A centralized policy engine, one service that answers "may they," keeps those checks consistent in a multi-tenant app where customers share the stack.
If authentication is strong, the application is secure. MFA, multi-factor authentication, OAuth, open authorization, and JWT, JSON Web Token, mean the inside is safe.
False! Once the caller is inside, Strong login does stop a stolen password at the door. It fails on what that user can see and do next. Separate authentication, who they are, from authorization, what they may do. MFA is a second proof of identity. What does a JWT actually prove? OAuth is delegated access, and a JWT is a signed token the API trusts. Neither stops excessive data exposure, returning extra fields, or business logic abuse.
Cryptographic failures only matter for data at rest. Transit is already protected because TLS, transport layer security, is on.
It doesn't work that way past the handshake. TLS, the lock on the wire, does protect data in transit. It fails once weak algorithms, keys, or certificates are wrong. Use modern algorithms and dedicated key management. Encrypt sensitive fields at rest and in transit. Hard-coded secrets in code leak with the repo. Validate certificates and store keys in AWS Secrets Manager, Azure Key Vault, or Google Cloud Secret Manager.
Security misconfiguration is rare because clouds ship secure defaults. Managed services come locked down.
Nope! And the breach reports keep proving it. Defaults do help on a fresh, empty account. They fail once a bucket, role, or console is left open. Public storage buckets and overly permissive IAM, identity and access management, roles still show up. So do exposed management interfaces, disabled logging, and default credentials. Enforce least privilege, only the access a job needs. Scan infrastructure as code, the templates that build your stack, with policy as code, automated rules on Amazon S3, Azure Blob Storage, and Google Cloud Storage.
Vulnerable and outdated components are someone else's problem. Managed services and containers handle the patching.
That one is backwards on the shared responsibility line. The provider does patch the hosts they run. Your app libraries and images stay yours. Your libraries and images stay your problem. Transitive libraries are packages pulled in by other packages. Keep a software bill of materials, a list of what you ship. Scan Amazon ECR, Elastic Container Registry, Azure Container Registry, and Google Artifact Registry. Allow only signed components so a supply chain attack, hostile code in a dependency can't land.
You only need to worry about the classic OWASP top 10. API and cloud-specific risks share those same controls.
Don't count on one list to cover the whole surface. The classic top 10 does name the common web bugs. It misses API and cloud failures that those controls never see. Add the OWASP API Security Top 10 to your threat model, the list of how an attacker wins. APIs add unrestricted resource consumption, letting a caller exhaust you, and improper inventory, APIs you forgot exist. Cloud adds metadata, SSRF, IAM, and CI/CD, continuous integration and continuous delivery, pipeline risk. These 10 myths hold up only as a known list. They break down once an API, a role, or a library sits outside it. Learn more at systemsarchitect.io. Like and subscribe to the channel and follow the playlist.